This is Geometry 6.3. We're correcting our 6.2 assignment, and based on questions, we'll answer questions. But please keep in mind, your cell phone should be off, your earbuds should be out, and if people think that that's different, the people who I have the most problems with those have the lowest grades in the courses that I teach. There's a direct correlation, man. Be here if you're going to be here. Okay, otherwise you're going to miss a significant amount of information. As we're looking at these answers today, please be advised that they are answers to questions that I would expect on quizzes, on the test. I'm not wasting your time because basically I'd be wasting my time. Okay, better things to do. 1 through 6, you talk to people about solutions. Are you okay? If they're either opposite angles of the same measure or consecutive or supplementary. All 6 of them are one of those as we look at them. But now 7 through 11 are their questions. Okay, 10. We did 7 and 9, didn't we? 9 and 11? Okay, so we did do 9 and 11. That's awesome. So those are all the off. Let's talk about 10. In 10, we got 4x equal 5y minus 2. And that's that AE and EC. And then we also have 2x equal y plus 14. There's a couple ways I can solve this. Okay, but the basic when we're really looking at these is get one variable set equal to everything else in the evaluation. So I've got 2x equal y plus 14. I subtract 14, I got 2x minus 14 equal y. What I'm going to do, where I see y in this other relationship, I'm going to substitute, okay? And that'll allow me to solve for one variable. So I have 4x equal 5 times the quantity 2x minus 14 minus 2. This ends up being 4x equal 10x minus 70 minus 2. And I'm going to subtract 10, negative 72, and x is positive 12. Okay, when I'm done with that. Now, after I make that relationship known that x is 12, I have this value, and remember we solved this here. Maybe I'll drop this down. We solved this, and now I'm going to take my 12, plug it in for x. So I got 2 times 12 minus 14 equals y. So 10 is equal to y. 24 minus 14, and my 10 is y here. So I used substitution. Substitution allows me to take equivalent value and plug in so I can solve for an unknown x or y. And when I need to do that, people are like, well, how do you know you're going to do that? It's when I have the values of x and y in my relationship. I cannot solve for both of them at the same time. I have to have a second relationship to help me solve, that I can substitute in a value from, or I know a value from to put in the number and then solve for the other one. Okay. Are there other questions? I mean, we did 9 and 11, now we got 10. How's 7 and 8 go? Were they okay? Promise. Okay. Yes or no? I can work them all if you want to see them, but which one would you like to see? 8? Okay, 8 and 11 are very much alike. You got AE, I got x plus 5 is equal to y, and I've got DE and EB, 2x plus 3 is equal to y plus 2. Now keep in mind, y is equal to 5 plus x, or x plus 5. I'm just going to plop that in right there. That's it. I just use substitution as if it were a number. And it is a number, it's just represented by a variable. And I plug those in. Now I just solve. I'm going to get rid of this. Maybe. So now I just solve, and I got 2x plus 3 equal x plus 7. Subtract x, so I got x plus 3 equals 7, and x is 4. Plop that back in. Excuse me. In. 4 plus 5 equals y, so 9 is y. That's it. It's just me solving algebraically. Okay? And 7 is done in a similar fashion. Matter of fact, if you haven't done 7, it's a good time to try it on your own, because this is pretty realistic to do on your own. Remember, this is review material from Expo. Okay? And depending on who you had as an algebra teacher in 8th grade, it's review material from when they had you, because they could have covered it because they've finished everything else at the end of the year in your 8th grade year. So this could be the second or third time you've seen it. And I know it's for sure the second time you've seen it this year because I've done it before, systems of equations. Be comfortable with these. You will have it on a homework quiz. You will have it on a quiz. You will have it on a test. It's not maybe. Now, in 12, when we're looking at problem 12, we're talking about this we have a transversal crossing 3 parallel lines that are all spaced evenly apart. And one transversal has been cut into even parts. All transversal gets cut in even parts. So NM and A is 4.5, B is 3.8, C is 9, D is 7.6. That's just you guys throwing back information that we covered in notes and I changed numbers. Okay. In 13 through 21, you're using opposite angles are congruent, consecutive angles are supplementary. You're using vertical angles. You're using linear pairs, they're supplementary. And you're using triangle sum theorem. All 3 angles of a triangle add up to 180. You're using alternate interiors from chapter 3. And you're using exterior angle theorem from chapter 4, 5. Okay, 4 and 5 that we've been covering. All those come into play on 13 through 21. So when I'm looking at 13, I get angle 1 is 105, angle 2 is 75. 14, angle 1 is 68, angle 2 is 118, angle 3 is 68. You've got to make sure you know what's going on with these. Now, I'll let you know a secret. This set of questions, you'll be given provided questions on your test for chapter 6 that helps your grade get to 70. The last 30% of the test determines your grade line from a C minus D, an A minus a B, okay? And that last 30% does that. That breaks it down. You've got to keep in mind that that's how that's going to happen, that last 30%. These are considered things that bring your grade to 70%. So 14, we read 15, angle 1 is equal to 54, so is angle 3, angle 2 is 102. 16, both are 60 degrees. 17, angle 1 and angle 3, alternate interiors, they're both 55, and angle 2 is 105. 18, angle 1 is 32, angle 2 is 98, angle 3 is 50. 19, angle 1 is 40, so is angle 3, angle 2 is 140. 20, angle 1 is 113, angle 2 is 45, angle 3 is 22. 21, angle 1 is 95, and both angle 2 and angle 3 are both 37. I will work any of those. Anybody got a question on them? In 22, the first one, the one on the left, the answer is 22. Excuse me. Okay? I was thinking, oh, I read the number, but it's actually question 22. The first one, let's call that the A problem. This is the B problem. A problem, A is 22. The B problem, A is 6. Any questions? 23. The sides AD and BC are equal. They're both 33. AB and DC are equal. They're both 13. Questions there? Yes, sir. 23? Okay, so the perimeter of a parallelogram, that's what that little shape means, parallelogram, is 92. Now, they told me it was a parallelogram. So I know stuff right off the bat before I even start. This and this, this and this. Okay, they told me A, B, C, D. They're saying, hey, AD is 7 more than twice AB. So I'm going to go, well, AB is X. That means the CD is also X. So 7 more than twice CD, 2X plus 7. Oh, hold on, kiddo, you got today's assignment. There. Okay, so now I know perimeter. Perimeter is equal to 2 times length plus width, and I'm told perimeter is 92, and I know my length and width, one's X and the other one's 2X plus 7. Now I'm off to the races. This one, all the setup is about reading this one phrase and knowing that perimeter is that. Okay? And that phrase is AD is 7 more than twice AB. Well, if AB is X, 2X plus 7. Done. Got it made. Now I just solve, I get that done, find out that this is 92 is equal to, that's 2, 4, 6X plus 14. Subtract 14, I get 78. And X equals 13. Well, if X is 13, that's centimeters. Then down here, 2 times 13 plus 7 is equal to 33. And that's centimeters. So that's all I'm doing when I get that done. But when you read this question, when you read stuff like that, you got to make sure you read it a couple times. Become a little bit more comfortable with it. Last two. These are straight up property ones. You're just circling which one's which. Now, keep in mind, this is completely here for review for the final and review for the test itself. Now, part of the review for the test itself, I'm expecting that you are following up for any questions that you have in any one of your assignments. You are keeping your assignments in your folder, nice and neat. You know exactly where they all are. They aren't loose. I've got a 3-ring binder punch for you, so that way they can be all together. If you need to, just staple them to your notes. Okay. I will be collecting the assignments on Thursday. Reason why I'm dragging my feet on it is I want to make sure you get it and you get time to ask questions. I'm not just taking it away from you. Now, please be advised that as the week is going to progress, we're going to be finished with section 4 tomorrow. Wednesday's a review. Thursday's a quiz on 6.1 through 6.4. Friday, final pretest. That's what we're going to use that day for. Now, the reason why I'm doing that, you get it done in class. Guess who has no homework from Bloom for a long weekend? Ain't that a nice thing? Pretty cool. But you just got to make sure that your note cards get to be used in class on Friday. You get to use your note cards that you've been getting ready for chapters 1, 2, 3, and 4. You get to trial run them suckers and see what you remember from them. Okay, let's get today's notes. Today, you are going to learn about the converse. And you're like, the converse? So we got the converse of stuff. And the converse has always been, we learned something about properties. And on Friday, we learned properties about parallelograms. We learned that if something is a parallelogram, opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Now today we get to learn the converse. The converse is when I have those properties exist in a four-sided figure, then I can call it a parallelogram. So if I have both sides of opposite sides congruent, then it's a parallelogram. If I have both sets of opposite sides parallel, then it's a parallelogram. If I have consecutive angles or supplementary, then it's a parallelogram. If I have opposite angles are congruent, then it's a parallelogram. If I have diagonals or mutual bisectors of each other, guess what? Then it's a parallelogram. And today we get to learn about one more item. When I have one set of sides parallel and congruent, it's a parallelogram. So that's what today is. Today is about the converse. Okay? So we're going to go about solving things converse-wise. But as we do these solves, I also want to bring into you the idea of systems of equations and how to avoid them. Okay, sometimes you can't, sometimes you can. So as we do these problems today, I want to make sure that we recognize situations where I have to use systems of equations and situations where I could choose to, but let's avoid it because it's actually a little faster to do it another way. So in this first one, I got y plus 3 and 2y minus 1. Well, gosh, those are both the same variable. And I got 3x plus 5 and 4x. So I've got these two relationships to set up and solve. So let's get after that. Remember, just like Chapter 5, Chapter 6 is you using a bunch of properties, applying them, and coming up with a solution. I expect to see the answers. I am aware that for some of you, oh, Bloom, come on, it's just easy. But you got to keep in mind, as a grader, I'm looking for the relationship you set up and the work you do to achieve your answer. I am not interested in the right answer. I am ultimately interested in the solution to that answer. So the solution helps you find the right answer, which is great. It's part of your answer as I'm grading, but I want to make sure you recognize it's the whole thing. It's not just an answer. Okay? I need to be able to communicate what your answer is. So my first one, x is 5. Just looking at it, we can see that. But I've got the setup, I've got the solve. You know, my next one might be a little bit hidden, but y is 4. Are we doing okay? Now, as we go on, I've got 4x plus 20 and x plus 26 and 7y and 6x plus 9. The 7y and 6x plus 9 requires me to have a value of x in order to find y. Since I have the relationship 4x plus 20 and x plus 26, and remember, opposite sides are congruent, I'm going to set that one up first and find x. And then use my x value, which should come out to be 2, to get my y. Now, keep in mind, I know the answer before I even started solving, but I'm going to show my steps. Okay, so I've got 3x, and I'm going to subtract 20. So I've got 6. Now that's where my 2 comes from. All right? I know my answer. I show the process because the grader requires it. Now, my relationship, 7y is equal to 6x plus 9. Use the fact, somebody got a little carried away here. Use the fact that I'm going to take my value of 2. Let me get rid of that. I kind of circled the wrong thing. I'm going to take my 2 and pop it right in for x. Now I got 12 plus 9, which is 21, and now I know my y is 3. Okay, so I divide, my y is 3. Are you okay with the process that I'm taking? Now on that one, I didn't have to do systems wholesale. I solved for x. I got a value for x. I used that value to help me find my y value. Well, I'm doing the same thing, setup-wise, side to side, in my C. Except in C, the last one, I have a mix of my variables. I don't have a choice with this, but what's really nice is that I know x represents 4y plus 3. So since x represents 4y plus 3, I'm going to plug it in right smack there to solve for y. Okay, so I'm off to the races. So I'm setting up to solve for y. Go get her done. Hopefully, we got that y is 3. Now, after I find that y is 3, I take this relationship right here. I plug in 3 for y. Okay, I find out that 15 is equal to x, and I'm done. Are there any questions at this time? Now remember, on this one I didn't have much of a choice. I had to kind of be careful in B on which one I started with. In C, after I made my relationships, set them up, I noticed the one that x was totally equal to 4y plus 3, so I didn't have to solve anything special for it, so I just plugged it in. Okay. Now, keep in mind, we're looking at things, properties that would require a four-sided figure to be considered a parallelogram. Opposite sides of the same measure makes it a parallelogram. Okay, so keep that in mind as we're going. The next one we're going to look at is consecutive angles are supplementary. Okay, consecutive angles are supplementary. Well, that means as I'm looking at this, I've got 4y plus 2y is equal to 180, and I've got 5x plus x, maybe, 5x minus 180 plus x is equal to 180. So that means I get to have 6x minus 180 as I go. But notice I could have set this up using systems of equations, because I could have said, hey, 2y plus 5x minus 180 and 4y plus x equals 180. But folks, if I can avoid setting up the systems, do so. I mean, avoid with reasonable support of properties, do so. So go ahead and get these solved. Get your solve on, get those done. Once you get those done, do the next one. Okay? Because at this point, we should just be practicing our solve. Okay? We should be very comfortable with the properties that we're using. It's obvious it's not calculator all the time. Yeah, okay. All right. Okay, just make sure that you're getting going on that. Uh, 6y, y is 30. Now, at this point, I'm already surmising that x is 60. Because I know properties of parallelograms, and if y is 30, 2 times 30 is 60. X better be 60. I better be coming up with a 60 here. Oh, and I am. Phew. Good. I'm right. Yes. Okay. Little fist pump. End zone dance party. Now, in B, it's your turn. Your choice. I would like you to consider the fact that in this section we are working on consecutive angles are supplementary. But you can use other properties if it will help. So go ahead and solve for the variables in B. Go for the biggies. Get the y's together first and think why you can do that. Okay, so getting after it, I've got my 12y plus 8 plus 5y plus 2 is 180. That's 17y plus 10. Subtract 10. Y is 10. Because 17 going into 170, it's 10 times. That goes pretty quick. But now, I know that y is 10. So I've got two choices. I can say 2x plus 5y plus 2 is 180. I can do that way. Or I can do it, I think I got it down there, or I could have said that 2x is equal to 120 plus 8, because remember, 12 times 10, and this way, and I could find out that x is 64 there, or x is 64 there. I don't care which way you got 64. Both work. Are you okay with the two relationships? Okay? It's your choice after you get the y's together. I'm okay with them both. Okay, moving on. We're talking about opposite angles are congruent. Okay, I just used that, but opposite angles are congruent. So check these out. Well, if opposite angles are congruent, then it's a parallelogram. Life is good. We're off to the races. Go ahead and do the setup. Look at what we got. Fill in your notes, and then just go ahead and solve what we're going for. We got y going on there, and then after you finish the first one on the left, do the one on the right. Remember, this is completely and totally for practice algebraically. Making sure that you know how to solve, but more so set up the relationship to solve. So in 3a, x is 8. And then I subtract y, I got 3y equal 87, right? Now, remember, you copying my stuff down doesn't help you practice your solving skills. Because if you got to copy these down after we've set it up, we've really got to talk if you need that assistance as we're going solving. Because I'm dividing by 3 and y is 29, not 19, but 29. You got to make sure you know what's going on here. Now in B, it's your turn. You've got the setup. Okay, you got y's, two y's, and an x. Which one are you going to use to easily solve and not have a systems of equations relationship? You got to be thinking about that. Okay, you want y's, two of variables of the same variable, two relationships, same. So although this is opposite angles are congruent, now 8y is equal to 4x minus 20. I get that. But I'm totally using 8y plus 10y, okay, here to solve for y first. And then I'm going to use that relationship of opposite angles. Okay? So once I know that, I've got this opposite angle thing going on right here. 8y is equal to 4x minus 20, or 80, because y is 10 now. 80 is equal to 4x minus 20, and I know x is 25. So in order for me to avoid a systems of equation problem, I have to be smart enough to realize my relationships have to be set up with the same variable each time. Okay? When I look at the problem, I have the options to set things up. I've got to be able to have be supportive with properties of doing it correctly. I just can't put things together because it's going to be nicer for me to solve. I've got to have reasons for it. It's got to be property-driven reasons, not just, well, because I just wanted to avoid systems of equations. Well, great, but if the properties aren't there, it's not going to be the right answer. Okay, so just make sure you are aware of that as we're solving those. Thank you, sir. Okay, so now, we've talked about opposite angles. Hey, let's talk about diagonals bisecting each other. Okay, so now I've got diagonals bisecting each other. And if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Well, again, I got this 2y plus 2 is equal to 2x. I got myself a 2y is equal to x plus 9. Okay, so I got these two relationships. But notice over here, I got this 2y kind of in parentheses. And people are like, why? Because 2y is equal to x plus 9. Now, this systems of equations idea, it's a substitution of value. Since 2y is also equal to x plus 9, it allows me to put in the same variable in a relationship. So in for 2y is x plus 9. I've substituted those. Now that allows me to solve for x. And people are like, why didn't you just solve for x? And it's like, I could have, but then I would have had fractions, but 2x is still 2x. Or 2y, excuse me, is still 2y, and I'm substituting in 2y is equal to x plus 9. So it works. So I get this going, x plus 11 is equal to 2x. I subtract x, and x is 11. Now, I use that in my other relationship. Remember, I use both relationships when solving a system. I use one to substitute, and that when I use the substitute, I substitute my answer back in to find my other value. And that's just not what we're doing. I don't know where that's coming from. So my 2y is equal to 20, because that's 11 plus 9, and y is equal to 10. Are there any questions about what I'm doing there? Other than that, we're in that world that 2x plus 14 came from, which is right here. Go ahead and solve B. Go ahead and finish solving B. You guys are doing a great job. Now, remember over here, I also have, maybe I don't, I've got 2x plus 14. Those are blue, 2x plus 14 and 5x. I also have that x is equal to 2y. Okay, where I'm going through and getting that done. So I got x is equal to 2y. 2x plus 14 is equal to 5x minus 4. Well, that's kind of cool, right? Because then I get to solve this, and I go, well, that's going to be 14 equals 3x. I subtract, I add my 4, so 18 is equal to 3x. So x is 6. Well, x is 6. 6 is equal to 2y, and y is 3. Those are my two values. I'm golden. They should work. And every one of these problems, you should be able to check your work. And I got pop in 6x, that's 12, 14, that's 26, and 6 times 5 is 30, minus 4 is 26. 3 goes in, and then for my x I got 6, and 3 goes in, I got 6, so totally works for my diagonals as well. Got it covered. I can check my work as I go. I don't need a key. It's there. Last one that we got today. If one pair of opposite sides of quadrilateral are both congruent and parallel, that'll work. But now I'm recalling from chapter 3 alternate interior angles. Okay? And remember, the same value, the same variable in the problem has the same answer all the way through. So I got this relationship, 3x plus 3 and 6x minus 18. That's golden, and I'm going to go and solve that right away. Okay, 3x plus 3 is equal to 6x minus 18. So I'm going to get that solve on, and I'm going to subtract 3x. 3 is equal to 3x minus 18, add my 3, and I'm going to get 22, or excuse me, add 18 and 3, I get 21, and 3x, and then I got 7 is equal to x. But now I'm looking at my angle values. And remember, I've got this set up this is all set up. I've got alternate interior angles here because these bad boys are alternate interior angles. So when I'm looking at that, I know 7y minus 3 is equal to 2x plus 4. I got 7y minus 3 is equal to 2x plus 4 because of alternate interiors. And I further know that x is 7. So 7y minus 3 is equal to 2 times 7 plus 4, and that's 14 plus 4, which is 18. I get to add 3, so 7y is equal to 21, and y is equal to 3. And I'm able to find my solution for both. Now, answer the last question. Read the theorem we just did and answer the last question. Well, can this figure be a parallelogram? Well, I've got one set of sides parallel and congruent. Theorem 612, 612 states that if it's got a side that's parallel and congruent to the other side in a quadrilateral, just one set, then they're parallelograms. Totally will work. Okay, that's the theorem, just regurgitating what I just learned. Throwing it back at me. Now, keep in mind, I expect you to finish your assignments. You have 15 minutes. Okay, I'm going to bring up the next screen. It's a chart that takes about 3 minutes for people to write down, but I'm going to let you start on today's assignment. Using the chart makes it go a little easier because all your properties are right there on it. So I'm going to get this chart set up for you. Now that you have all the stuff in the chart, I'm just going to make sure I'm not shortchanging you. You can take your chart on the next page, fill that out. We will start with the bottom tomorrow, but after you have the chart written down, you'll be able to have everything you need to be successful on today's assignment right in front of you. Okay, for those folks at home, you guys can just freeze the video and get that going. For those folks here, I'll just keep this screen up. And the assignment is out.